So guys settled in? I think we'll start. Hi everybody, my name is Hari Krishna Menon. I'm a program manager in the XAML experience team in Visual Studio. And today I'm here to talk to you about the new XAML tools in Visual Studio 2015. I hope to make this, this whole session concise, short, and as demo heavy as possible. So if you have any questions, feel free to come up to the mic and ask the question because this is being streamed live as well. So it's easier for people online to hear your questions and for me to answer it. Also, we'll have a dedicated 10-minute set at the end of the session for Q&A as well. So the agenda for today, first we'll talk about the new language service, XAML language service we have built for Visual Studio 2015, RC. What we have done is we've done a complete rebuild from ground up for this particular component of your authoring experience, and we'll go about in detail of what that entails. The second one is Blend for Visual Studio 2015. Blend has changed dramatically this release. It's not based on the old Expression suite of products anymore. It's actually based on VS Shell itself, and thus it has a lot of new functionality that comes from VS. And we'll go over some of those new capabilities of Blend. Then we'll take a look at the new suite of UI debugging tools we have built for XAML. There's a whole set of debugging experiences exclusively for XAML views that we have built into the Visual Studio debugging experience. And we'll take a look at some demos there. And finally, we do have a set of profiling tools, new profiling tools for XAML, and we'll take a look at those tools. All these features that I've talked about, I'm going to demo in the context of WPF for this session, but rest assured, it works for Windows Phone 8.1, it works for Windows Store 8.1, and it works for UAP applications as well. But I'm just going to do most of my demos in WPF. Finally, we're going to look at a couple of instances of doing adaptive applications in UAP and how Visual Studio can help you build those applications. So, the new XAML language service. For a couple of years, we've been hearing a lot of feedback from our customers, including you guys, that, hey, sometimes the XAML IntelliSense just disappears on you. Sometimes it's quite slow. The reason for that was the XAML language service was always driven off the designer, and the designer was a separate process. And because the designer always gave you what you see is what you get, like a really high-fidelity design experience, we had to run your code. And sometimes customer code or user code behaves weirdly when it runs in the context of the designer. And that causes a crash, and that causes things to go down. So what we have done this release, we have taken the XAML language service and moved it to the Visual Studio host. We have rebuilt it on top of the Roslyn compiler platform, the new .NET compiler platform. It is extremely fast, it's very reliable, and it is the foundation for us to build new cross-language refactoring features going forward. For example, think about a scenario where you want to actually change a property name somewhere, and that property name is used in XAML. We can now do that because XAML basically uses the same symbols that Roslyn works on. So we have a very good relationship with the other language services right now in Visual Studio. And we'll go over a couple of other features as well. So without talking about it too much, I'm going to shift to the demo. Give me a sec. So I talked about how we have redone Blend this time around. So we thought, hey, why can't we make Visual Studio a code-centric experience for our customers? For example, let's say I open main-window.xaml. This is what you get, right? You get a designer, you get the XAML view, split view, all is great. What if you wanted exclusively just the code to work with? Now, in 2015, you can go to Tools, Options, go down to XAML Designer, and you can turn this off. When you turn this off, you no longer will get a design process. You won't get any more designer windows. It'll be exclusively just the XAML editor, like you would see in C#, but you'll get full IntelliSense. You'll have all the awesomeness the XAML editor has, but without designer process running. So to demo that, I'm going to click OK. I'm going to close Visual Studio, because once I set the option, I need to restart VS or close the solution. It's easier to just restart VS. So I'm going to select the same project again. You can see that main window now just opens by itself. There is no designer. There is no document outline. There's none of the other designer windows anymore. And to just prove that we have IntelliSense, if I do, you can see that we get full IntelliSense here as well. So this is some folks have issues with the designer taking too much memory and things like that. And those kind of situations, you can just turn it off and file a bug with us, and we can definitely fix it going forward. So this gives you an out that way as well. So how many of you know about Peak? Peak? So I'll demo Peak first. So Peak was a feature that the C# language team introduced language service team introduced last year in 2013. So what Peak allows you to do, let's say you have, this is my code behind, and Metro window comes from a third-party library. I could just do right-click, Peak definition, and what happens is Visual Studio will bring the definition of the symbol that you're trying to look at in C2. That means you don't have to navigate to a different page. Imagine that's a function. It'll work exactly the same way. You can instantly look at your definitions without ever having to navigate from the file that you're currently viewing. We've actually brought this concept over to XAML as well. So I'm going to close this. I'm going to switch back to Visual Studio. Switch back to my XAML file. And I'm going to do the same operation, Metro window, on Peak definition here. You can see that now XAML has the exact same object browser or definition browser that the C# and VB language editors have. Let's try another scenario. You can see that I have an xcolon class. This points to my code behind file. I'm going to right-click, Peak definition. And what if I wanted to change my name of my main window? So all I have to do is actually, let me type project tracker. Oh yeah, that's caps, horrible. But I'm just going to go ahead and hit rename. Did you notice something? The xcolon class also changed. So we are now able to actually use Peak, do some refactoring operations, and make sure those changes are reflected correctly across XAML as well as C# and VB going forward. So that's pretty sweet. I'm going to undo this change. The class name looks horrible. I'm going to go on one more quick demo. So let's say you're editing a XAML file, and you have you have an event, and you want to quickly peek into the event. You don't have to actually navigate to that event anymore. All you have to do, again, is right-click, Peak definition, and you can edit that event definition inside XAML itself. So you have the full C# language service running inside Peak in this instance. So do you guys know about regions, right? In C#, a lot of people use regions. Some people hate it. Some people love it. So when we asked this question on Twitter while starting this product release, we got a lot of mixed response. Some people said, hey, XAML is extremely verbose. We would love to have regions, to demarcate certain parts of UI. Some people said, no, it's bad. It's a code smell. You should not have it. But it was kind of really cheap for us to do, so we thought, hey, why not? There's a certain class of folks who would love to use regions, right? So let's just go ahead and do it. So we actually introduced regions in XAML. So I'm going to do a quick demo so how we can use regions. Let me open my timeentry.xaml. You can see that I have a bunch of separate creds and whatever, right? What you can do now is switch. You can start typing, say region, let's say my region. Come back over here and complete it. So at this point, I can basically collapse this region exactly like you'd expect in C# and VB. So this makes it very easy for you to name areas of your code going forward in XAML. XAML is pretty verbose, so if you have a huge XAML file, it might make sense for you to group things together and put a region around it. And you can see that we have actually used comments here. We have actually overloaded the concept of comments to use it. So this file is still XML valid. It's still a valid XAML file. We haven't really introduced any new syntax. We've just used a special type of comment and made the editor recognize it so it actually does the right thing. So that kind of wraps up my demos around the C# language the XAML language service. I'm going to switch to my slides for a bit. Okay, now let's talk about Blend. So when we did Blend around 10 years ago, I think in 2007 or 2006, we imagined it as a tool for building great user experiences, a tool for you to exclusively focus on your design-oriented tasks. On the other hand, we wanted Visual Studio to be a code-focused and a debugging environment. And in this release, what we did, when we looked at all the feedback that we had over the years, this is what we heard most from our customers. Hey, the quality of your IntelliSense in Blend is going pretty low. We had decent C# IntelliSense, decent XAML IntelliSense. Right now, the last release, we didn't have IntelliSense for Windows Phone or Windows Store. The second one was when you have Blend and VS open together and the same file or same project open in both products, you start making changes, you get these dialogues every second or so asking to reload the project or reload the solution or reload the file. It's extremely irritating. Basically, you can't really interoperate between both products successfully. Then they were like, hey, your project system or your solution explorer is like light years behind Visual Studio. You don't have decent source control support, no support for solution folders, expand, collapse nodes, etc. And finally, VS, I don't know if you know about this, supports what we call asynchronous solution load. If you have like a solution with, let's say, 300 projects, VS is able to load individual projects asynchronously so that you're able to start working as soon as you open the project instead of having to wait for like 5 minutes or so for all the projects to get loaded. So this makes it, so this was some of the feedback that we got saying, hey, you guys don't have this in Blend. So what we did is we have rebuilt Blend from ground up using VS technologies. It has almost all the features that we previously shipped in Blend in Visual Studio 2013. There are some features that's not available in RC yet, but we're working towards getting enabled in RTM and the next update to Visual Studio 2015. And this is the start of journey. Now we can actually focus less on infrastructure and let VS do all the heavy lifting in terms of Solution Explorer and Team Explorer support and focus exclusively on building great design experiences. So I'm going to switch back to my demo now. Let me just re-enable my XAML designer for a sec. I'm going to open main window. I'm just going to keep app.xaml open as well. You'll see why pretty soon. So now we have a new command called design in Blend. When you click on the command, it opens a new instance of Blend with that project open. Previously, this command was not available for WPF. Now this command is available for all XAML platforms, period. So you can see that it opens. This is a new Blend for Visual Studio 2015. I'm not sure of the projector. You can see through the projector, but the theme is slightly different. What we did, we took the base Visual Studio Dark theme and improved upon it. What we mean by improved, we made it so that there's a higher contrast ratio so that contents pop, right? So it's easier for people to let the Chrome fade to the background. So if you go to Tools, Options, you can see there's a new theme called Blend. And if you choose to have switch to other themes, you can totally do it. You can just switch to other standard Visual Studio themes as well. As you can see, the tools options are exactly the same as VS. All the options in previous Blend has been carried over to the new Visual Studio, Blend as well. And all these options, just like VS, if you have a connected account, roams. So all your settings now roam with Blend as well. So that's pretty awesome. Another thing to notice is if you look at all these, the top level menus, it's kind of simplified. So if I open, let's say, team or project, right? It's actually much smaller than what you would expect in VS. We have really trimmed out all the packages, all the extensions, all of the features that we think are not necessary for a design-oriented workflow. For example, profiling. We just removed that package. So a whole bunch of associated infrastructure and commands just went along with it. So we have really simplified the user interface, commands, tools, options, and blends to make it easy for you to focus exclusively on design. Now I'm just going to go over some of the features that we have got for free when we started rebuilding on VS. The first one is a Solution Explorer. It's the exact same Solution Explorer that you have in VS. So you have the functionality like collapse all nodes or expand all nodes. You can create solution folders. Previously, we never had that feature. So if you had files under solution folder would just show a flat list of files in your project. That's no longer the case. So it's exactly the same Solution Explorer. We have the same Team Explorer as Visual Studio, so that means you have full TFS and Git support, exactly how you would find in VS. Blend favorites, like let's say the assets pane, has been brought over. We don't use the VS toolbox. We believe assets pane is a little slightly better than the toolbox because it has better categorization, and it's easier for you to pick up controls or find those controls in the asset pane. States pane for creating and editing visual states is available in the new Blend. Triggers available for WPF applications. Sample data, again, available. Properties and resources. So as you can see, everything that you're used to in the old Blend has made its way. Some features like Illustrator import and things like that, we're still working on it. It's not enabled in the new version yet. Another thing that we have moved over is Blend had a traditional workspace manager. We have now moved over to the VS workspace manager. That means I can go to Window, and let's say this is my standard my standard template that I use, my standard workspace that I want to use. All I have to do is go to Window, say Window Layout, and I'm going to call it Standard, or let's call it Design. That was what previously Blend was called. So I'm going to call it Design. Click OK. And now, if I want to have a separate workspace, let's say for heavy animations, what I'm going to do, I'm going to create a new animation. Drag this a bit further, make the timeline a bit more prominent. Now I can go back to my window and save this layout as animation. And it's very easy if you want to switch between different workflows. It's very easy for you to just go to Window and apply window layout and switch between animation or switch between my standard one, which I'll do in a second. Sorry. I can switch back to my standard, as you can see. This is going to go away in a sec. I'm going to stop my animations, and I'm good. OK, so we have the same window layout manager that you would expect in Visual Studio in Blend as well. Now I want to talk about a new feature. Have you tried out 2013, what we call in-place editing? So in-place editing was a new feature that we built in the last release. And I'll show a quick demo of that, and we'll show you how we improved that in this version. So I have here a tab control that has 2 tab items. I'm going to select the first tab item, and I want to edit the template of this particular tab item. So I'm going to right-click, Edit Template, Edit Current. What you can see is that if you look at this particular template, my tab item template is coming from app.xaml. But in the new version of Blend, you no longer have to navigate to app.xaml to edit your templates. Even if those templates are coming from different resource dictionaries or app.xaml, you can always design those templates within the context of the view you're editing. You will never be navigated out again. And if I drag up my XAML editor, what you can see is we have used the power of Peek to bring in the resource that is from app.xaml into the same editor that you're currently designing, that you're using for designing. So let's say if I want to change the background from transparent to red, I make that change, and you can see it instantly reflects on the design surface. But I'm actually editing a separate file. So using Peek and in-place editing, it's very easy for you to design your controls, your custom controls, or your templates going forward. Let's see this again. One thing you might have noticed is that we have the exact same IntelliSense in Blend that is running in Visual Studio. The same language servers runs in both products. So you have full-fledged IntelliSense for all platforms in Blend. So you saw that I made a couple of changes, right? And all these changes are being changed on app.xaml. I'm going to switch back to VS for a second. And you can see this dialog. People hate this dialog. This basically tells you, hey, some file has been changed outside that was open in VS. Please reload. But in this release, what you could do is you can click this button, say yes to all, and you can see now the change has been reflected. Now if I go back to Blend and let's say I make my value this back to red again, and I switch back to Visual Studio, it never asks you for a reload. It instantly updates your file without you having to worry about it, and the changes reflect in the design surface. So you can use these both. OK, go ahead.
Did you save in Blend?
Yes, you have to save. So once you save, as long as the file, you have to check that option. It is available in Tools, Options, Documents. It'll automatically update your view in VS. You don't have to switch between and do reloads multiple times anymore. So one last Blend demo. Blend is now completely accessible. We had complaints from power users that, hey, we tab a couple of times, it kind of ends up nowhere. Or I can't really use common things like F2 for renames and things like that. But that's no longer the case. All panels in Blend are completely accessible and can be keyboard driven. For example, if I have a resource, I can just do an F12. That was not fair. I'm going to go to a new resource. Let me just tab. Yeah, somehow it's not working. So yeah, it's selected. If I do F12, you can see that it puts in rename. So all panels in Blend can be completely driven from using the keyboard going forward. So that's it for Blend. And stay tuned. Hopefully, by RTM and a couple of new updates, we'll have much more design-centric features that they're going to come to Blend. So switching back to my slides. Yes, community, professional, and enterprise. Express, however, we are only available in desktop and Windows. We don't have a version for web, so the web support, HTML support in Blend has been removed in 2015, so we no longer support Web Express. So this is probably one of my personal favorite features. This is what we call the UI debugging for XAML. So UI debugging for XAML is a complete new set of tools. A lot of you might have used Snoop or other third-party like XAML Spy and stuff. Think about XAML Spy completely integrated into VS. You have a live visual tree. You can inspect all the visual elements of your running application. You can see its properties. You can modify those properties, and those properties are reflected back in the running app, and it completely respects the debugging workflow. That means you can debug on a remote device, simulator, emulator, remote machine, doesn't matter. So it's just a core component of the debugging engine on Visual Studio going forward. So let me switch to I'm going to close Blend. Let's focus. I'm going to open the same project, but a different copy. I kind of messed with the whole project before, so I'm going to fresh start. So I'm going to quickly F5 an application, show you the application I'm going to use to show the rest of the demo. It's a pretty simple app. All it does is a simple project tracker kind of demo. It shows you can input your hours for a certain project, and it shows what you've been up to, what different users or different tasks been up to. It's pretty simple. And I'm going to use this to talk about the UI debugging tools. So you have the app here. If I switch back to VS, you will see two new windows. One is called the Live Visual Tree. The other one is the Live Property Explorer. If you can't find it in your version, just go to View, Debug Windows, and you should be able to find it there and open it up. So what the Live Visual Tree does, it shows you all the elements that is currently being displayed or part of the visual tree in the running application across different matter. If it's multiple windows, doesn't matter. All of them will show up here. And an awesome thing about this, the tree, it's live. That means, let's say if you look at the element count, it is 933. If I switch to time entry, you can see it instantly reflect to 619. That means we continually update the live visual tree based on whatever we see on the screen. You don't have to explicitly refresh or do anything. If I click on report view, you can see I'm adding a lot more elements again. And still, the count has increased. So it will continually listen for changes in the running application, and we'll update our visual tree going forward. So this makes it very easy for you. You don't have to think about refresh or inspection. We'll make sure your selection is always current. We also support full search. For example, if I do tab, we will highlight all those with the tab in the name or in the control name. We can either name a control or the name of the control. We'll filter the view with that. So it's pretty easy for you to quickly find elements using search. We do have a refresh button. That's because we think we have covered all scenarios, that we know exactly when things are changing. But for some reason, if you think the view does not reflect what you're seeing on the screen, we encourage you to click that button. But hopefully we'll get rid of it pretty soon. We're like 99.9% sure, but we're getting there. Hopefully we'll get that out by RTM. So you'll probably never have to use it. And if the Live Property Explorer is not showing up, clicking on this guy over here will bring up the Live Property Explorer and shift your focus. We also have common concepts like collapse all nodes or expand all nodes. Probably not a good idea because that kind of kills the perf. And the next feature I talked about is source synchronization. We did a bunch of work, even in the WPF platform, to enable surfacing source information. So we now know exactly what kind of elements are created, where in your code that elements are created, especially when you're debugging. In attach, you might have a slightly degraded experience because if you don't have an active project open, it's kind of difficult for us to map where your files or your source is coming from. Because XAML does not have a symbol file, unfortunately. So we have to basically do some kind of math between what we know from the platform and what we can see on your file system. So if you see main window here, I can right-click and say View Source. And you can see that it opens main window and highlights a control that I've selected on my document, on my live visual tree. So whenever we know that this element comes from XAML, we'll let you go to that source. It's pretty easy. So you'll always know where these elements are declared in XAML. It doesn't matter if it's coming from a style that comes from an XRD somewhere. We'll know exactly where that is, provided you're debugging and not attaching. That's just the caveat. Let me close these windows. Sorry. If you want to automatically synchronize your selection, what you can do is you can click this guy. What this means is that whenever we find an element that we can go to, for example, code tab control, we synchronize the XAML in real time. So some people like it, some people hate it. They don't like your view jumping around, because especially if you're viewing a piece of code. But you can turn on that feature. If you don't have that feature on, you can right-click and do View Source. But there's 1,600 odd elements. It's almost impossible for any of us to know where the element I'm interested in. It's much easier for me to pick that element from a UI. So we have an element selection feature. So what you do is you click this button over here. It enables element selection. And once I switch back to the application, you can see that as I hover, I'm showing the outlines of those elements. At this point, there's kind of a glass on top of the app, so you can't really, there's no input going. We're just drawing these things on the surface of the application. So let's say I'm going to select time entry, and you can see that we instantly synchronize the selection to the text block, basically because we're selecting the deepest element under the mouse. Even though you're clicking the tab item, the text block takes the entire space. So the selection is a text block. But if you want to select tab item, it's just above here. You can quickly go and select the tab item. So live element selection sometimes is much more easier and more intuitive for you to pick up the elements in question. We have another feature. Once you have enable selection on, you can also enable layout adorners. What layout adorners do is basically it basically draws guides for the element in question. So for simple scenarios like, hey, if I select a node, I know the size of the node element as well as the margin. So if you look at the yellow space, it tells you the margin that's been set on that control. So it's very easy for you to, without having to look at values in Property Inspector, understand why an element is laid out using the layout adorners. Or you can toggle this feature on and off. Some folks hate it again. So I'm going to turn it off for this demo. So that sums up what the live visual tree can do for you. So this feature is available for 8.1, Phone 8.1, Windows Store 8.1, but running on Windows 10. applications, but running on Windows 10, and WPF applications running pretty much everywhere. So we support all XAML platforms, except for Silverlight. That's not supported. The problem is we actually have to build separate logic for each platform, because all platforms are different, XAML platforms are different, right? So we write separate layers to talk to each platform, so it's pretty expensive for us. So now let's take a look at the Live Property Explorer. The Live Property Explorer basically shows all the properties of the elements that are currently selected. So here I have the tab item selected, and you can see all the properties of tab item. We've done a couple of things here. You can search for properties that I'll show in some time. But if you look at it, we have actually categorized all the properties into different groups. People experience WPF or other XAML platforms know for a fact this is basically value inheritance, right? It's how a value is set and the winning value is calculated in a XAML platform. In WPF, if you coerce a value, that in the dependency property, if you actually coerce a value, that wins above everything. It doesn't matter if you've set the value locally, coercion always wins. If you have the value set in XAML, in line on your element, that is the next value that wins. Values that come from the style applied to it is the next in line, so on and so forth. So this is the order in which values could be set on an element and where those values are coming from. Why this is awesome is because you can actually predict, for example, the classic question, why is my button red? Is it coming from my style? Is it coming setting inline? Is somebody coercing it? This will tell you. And if somebody is overwriting a particular value, for example, is selected as being overwritten by the platform tab control itself, you can see is selected as actually struck through. That means that value is no longer respected. Is selected is being set coerced by the platform control itself. So this instantly tells you why certain properties are set and why certain properties are winning. You don't have to actually query the control anymore. This organization makes it super easy for you to understand that. Let's do a couple of demos to illustrate this, right? I'm going to go back to my favorite element selection tool, switch back. I'm going to select this tab control again, tab item again. Select the text block. I'm going to go select the tab item. You can see the background property for this tab item is coming from a tab item style. So you can see that I have a dynamic resource tab item style set, and that value is coming from that. I actually can even go to source on that property. If I go to source, unfortunately, we kind of take you roughly somewhere there. It's going to get fixed in RTM. That is an offset thing. So it takes you somewhere in the vicinity. You have to scroll a bit up and down, but in RTM will be exactly on point. Yeah, so you can see that the background is set to some value. I'm going to change this style value. So this style is applied to two tab items. I'm going to make this green, hit enter, wait for a moment, and you can see both tab items' background is now set to green. That means I made a change to a single style, and we made sure every element that is using that style is refreshed with the new value. But what if I want to change a single tab item? I can do that by going back to the PI, go to local. I'm going to set locally because local is going to win style, right? Like we discussed before. I'm going to hit new, go down, select background, and make that red. Hit enter. You can see that when I made background red, the style from background got overridden. So it's easy. Now you can see that, hey, local values trump values from styles, and we override that value. And I switch back to the application. You can see one of the tab items is red because I set the value of the background for tab item locally. I can choose to completely reset this experience while I'm debugging. I can reset my background from style. I can reset my local value, switch back to the app, and I can see the value has been pretty much taken away from both style as well as local while the application is running. So this is pretty sweet. We hope to, this is pretty much at this point, all the changes are being made to runtime applications. In RTM, we hope to serialize these changes back into XAML. So it's a true XAML edit and continue experience. If you want to make tiny tweaks, you can make it while you're debugging. And once debugging is stopped, you can just save all your changes, just like you would do C# or VB. So that we hope to have a true edit and XAML edit and continue in RTM. Right now, It's all of the running application.
So is that changing? So that right now it's not changing the XAML?
No.
It will?
It will change the XAML. So basically, the experience would be all the changes that I could make that we know you have source for. We'll make that change, leave the files unchanged, like unsaved, and once you stop your debugging, you can choose to save separate files or the whole files. But that is not yet done in RC version. We're very close. So collections in XAML are pretty important. Pretty much a lot of important properties. Sorry. Go ahead.
I use Snoop quite a lot.
Uh-huh.
It's invaluable when,
Uh-huh.
when you're trying to figure out your visual tree, right?
Mm-hmm.
Some of the things that this stuff looks great. Some of the things that would be great to incorporate as well is the selector tool,
Mm-hmm.
having the ability to change what color that thing is, how thick it is, and stuff like that.
The guides and everything.
Yeah, it's really subtle on the screen.
Uh-huh.
Your app is crazy looking.
Uh-huh.
It can blend in with some of the elements.
Absolutely makes sense.
Two other things that I use out of there that would be great to have. I know that you guys are probably tied up on features, but one is the ability to rotate in a 3D viewport.
Mm-hmm.
Like to be able to see your whole app in layers.
Yeah. We actually have a prototype. One of our interns wrote it. We're kind of figuring out whether to check it in or not. Hopefully, we're going to invest heavily in this feature set. So over the next RTM or update one, you'll see some of these features that you're talking about coming in. But that's great feedback. Thanks for that for the selection thing. That totally makes sense. I'll pass it on to the PM working on the feature. So coming back to the demos, right? We showed how to change simple properties. But collections are pretty important in XAML. Rows, columns, gradient brushes. There's a whole bunch of things out there that are collections. We actually enable you to edit those as well. To show a quick demo, I'm going to switch back to my app, select this root border over here, or grid. I have the grid selected. I go to my row definitions. I'm going to row 1, and instead of auto, I'm going to make it 200. Hit enter, come back. Oh, you can see the footer bar is now 200. It looks horrible, but illustrates a point that you can edit any collections, including brushes, rows, columns, using this tool. Finally, I know a lot of people really like the Silverlight 5 experience in the editor where you could put breakpoints and actually debug data bindings, which is pretty awesome. We completely agree with that experience. That is a great experience, but we haven't had time to implement it this release. But what we have here is something that will really help you debug data binding issues. To show that, I'm going to switch back to the app. Let me stop my element selection. Yeah, you can see this guy over here, the hours is empty. Pretty much all other combo boxes are being bound and displayed correctly. So I'm going to switch back, select the element selector, go select hours, and you can see we synchronize instantly to that particular template. I'm going to select the combo box control. It's actually pretty easy for you to figure out that, hey, I kind of screwed up my hours spelling. That's probably what the reason is. But other way to solve this problem is go to the live property inspector and search for data context. Sorry. You can see the default data context has been overridden from an inherited data context. And if I expand the data context, we show all the CLR properties that's coming from a view model. So I can see, hey, there is a property called hours, but I'm actually binding, I'm not giving the right name here. So if I just correct my spelling, it's easy for me to fix it. I can even inspect individual values of that CLR property. So it makes it super easy for you to define, hey, why is my binding not working? It's probably very easy for you to quickly inspect your data context on your parent element or the current element and see what could be wrong with your binding expression or how we are setting the data context itself. So that wraps up my UI debugging tools demo. Before I switch to profiling tools, do you guys have any questions on anything that we have had so far? Hi. Sorry?
Would you not normally put in the designer part that know that the property would underline property focus in the backend?
Oh, actually, no. We don't. Unfortunately, don't have the behavior. We don't validate binding expressions. But you're right, if you had the expression, you would never end up with this. We never validate bindings. Because your data context can be set in code, like this data context is to something, we have no idea in XAML what the data context at that point could be. Oh yeah, absolutely, you could do that, yes. If you have a equivalent design context, yes, that makes sense. But without, a lot of people we have seen never does, they don't actually do data design. They just sometimes just load a bunch of objects using, from the database something, while in design mode, design their views. So switching back to slides. So as I said before, the upcoming features we're going to do is serializing all your edits back into source, so you have a true XAML edit and continue experiences. And we're going to invest heavily in data binding. Like, for example, we want to show you all the 5 failed bindings on a page, so you can quickly figure out what failed. We can tell you all the successful bindings on a page. Some successful bindings are probably not what you would expect as success. And you'll be able to inspect those bindings and see how the binding expression reached that value. So we're looking at different ways of building these tools in the near future on top of the existing live visual tree and live property inspector. Now on to profiling tools. In 2013, we added a bunch of new tools for XAML platforms for profiling. We had CPU, we had memory. In this release, we have timeline and network. Timeline is a replacement for the XAML UI responsiveness tool we shipped earlier for Windows Phone and Windows Store. Timeline tool now supports WPF as well. Network currently only supports Windows 10 applications. Hopefully, we'll be able to add support for that for other XAML platforms as well. It is currently only available if you're running on operating system Windows 8 and above, but our Windows 7 support is coming really soon. CPU usage actually is supported on Windows 7 in RC. Other tools will be enabled at RTM. So I'm going to do a quick demo of Timeline tool, because that's where we invested the most, and that is exclusively XAML. I'm going to reload this project. There is a reason that that project is reloaded. Otherwise, my source synchronization wouldn't have worked in UI debugging. So I was smart. I'm going to set the startup project. It's a very simple app. All it does is take a bunch of codes from the server, from Yahoo. Oh, sorry. Thank you. I would have gone on for minutes otherwise. This application, all it does is download a bunch of stock codes from Yahoo and shows in a couple of graphs. And what I've noticed, I'm actually debugging this app. It takes freaking forever for the app to show up. Like, it's actually deployed. It's just taking forever to start up. And I really want to figure out what could be the issue here. So I'm going to stop profiling, go to debug, start diagnostic tools without debugging. You will see all the diagnostic tools available for a particular application type when you open this diagnostics hub. I've already selected CPU usage and timeline. I'm going to click on Start. At this point, we launch the application under the profiling tool. All the information that we collect in this profiling session is in the ETW format. So if you prefer other tools like Windows Performance Analysis or Perfview to view these traces, you can just unzip the session files that we create and open those tools as well. So we follow the same standardized format that most Microsoft performance tools use. So I'm going to stop collection. And we're basically crunching through a bunch of performance data. Here, at this point, we have finished profiling. We create a bunch of graphs. The first one is what we call UI thread utilization. As most of you know, one of the easiest ways to have great performance for your application is to keep your UI thread as free as possible. Don't run too many computations or large problems on the UI thread. If you keep that free, your customers you'll feel a much better application responsiveness. So we basically tell you all the XAML components and the associated utilization of the UI thread. For example, you can see for a long time, the app is pretty much, the UI thread is completely blocked by things like parsing, layout, render, disk input or network input, and application code. So the utilization is broken up into these individual components. The second graph is visual throughput. It tells you the frame rate of a UI thread and the frame rate of the composition thread running in the desktop window manager. Here, the most interesting thing to us is the UI thread. You can see when the application starts up, it's essentially 0, right? There's no frame rate. That means something is really it's the first frame that the application is trying to create is taking forever, almost 8 seconds. And if I come down, the details view tells you all the events of interest in your app. We create certain events for you to point out scenarios of interest. For example, application startup, that is an event that we generate and input in the tool. So if I want to debug application startup, all I have to do is right-click and filter to event. At this point, we filter the graph to the time slice that the application took to actually launch. And I can actually leisurely inspect each individual event after that. We show things like parsing. You can see parsing is pretty much the biggest culprit. It's taking around 6.33 seconds. Parsing is not just reading a XAML file. It's also reading and creating the XAML objects. So let's say you have a bunch of resources. The parsing cost will tell you if creating those resources is also taking a time. And here you can see that if I expand main window, it looks like main window is the biggest problem, right? Main window itself being parsed and being created is taking over 6 seconds. It also will tell you all the resource files that have been parsed as a result of parsing page A. So the whole XAML parse tree is represented in the parsing event and the individual cost for those parsing events. If I scroll a bit down, you can also see layout. If you see layout, we'll tell you the visual tree that took part in the layout and the cost of each element in that layout. So let's say you have written a custom panel that has a lot of logic. If you have a bug in that logic, you might see significant layout times, and you can troubleshoot those kind of problems by looking at the layout event. It'll tell you the cost per element in the visual tree for taking part in the layout pass. And all these events, by the way, are running on the UI thread. So I'm going to right-click on main window and further narrow my field of view to know that, hey, this is what my problem's happening. And I can't really use this tool at this point because it's giving me as much information I can that says that the main window is a problem. I'm going to switch to the CPU usage tool. And you can see in the time slice, and this is where cooperative profiling comes to picture. In Visual Studio, you can start multiple profiling tools together, and this enables you to correlate issues across different kind of profiles or different kind of performance metrics. And here, I can see my main window constructor took like 56% of my total CPU time. If I keep expanding, you can see the culprit looks to be my model constructor. It's taking almost 53% time of my startup. All I have to do is right-click and go to View Source. And it looks like I'm doing get data. This get data method is taking a long time. So let's see how we can troubleshoot it using another set of diagnostic tools. I'm going to put a breakpoint, start of the method, end of the method, and start debugging. You can see the first, the debug breakpoint got hit. And if I continue execution, you can see that it's taking quite a long time. It finished. And the new feature called perf tips, which is available in Visual Studio, tells you the time taken between each function call or successive breakpoints. So it's very easy for you to quickly do simple math calculations to see, hey, is this call to my database? Is this call to my network service taking a long time? By just F10ing or just moving your breakpoints along. So this is how you'd use debugging and profiling tools in conjunction to solve some performance problems. So I know this method is my problem. I know for a fact it's running on the UI thread. Easiest thing for me to do is run it on a separate thread. So I'm going to stop debugging. I'm going to just wrap this call under a different thread, start execution. I know you might be thinking there's no way that code's going to run, right? But I've taken my due diligence to make sure it runs after that. So it's like, I don't think anybody's got to solve the problem by just running on a different thread, but I made sure the rest of the things are all set up. So I'm going to continue execution. You can see that, hey, it just took 4 milliseconds. From over 5.4 seconds, it just took 4 milliseconds to execute. And if I continue my execution, you can see some sort of UI came up. As soon as I'm getting data from a network service, it automatically populates my UI. So using perf tips while you're debugging, as well as profiling tools, you can come up with, you can troubleshoot many scenarios in your XAML applications going forward. And to reiterate, this tool works for Windows 10, Windows Phone 8.1, Windows Store 8.1, and WPF. Not yet. RTM, this tool will work. RC, only CPU usage tool, works in Windows 7. But memory and timeline is going to happen. So I have pretty much completed the timeline tool demo. So I have 2 more demos. I'm going to show a quick overview of the memory tool that we built in 2013, but we did a bunch of improvements to the tool over 2013 updates that we didn't really talk about in any conferences. I'm going to show a couple of quick overview there. To do that, I'm going to go back to my favorite project tracker application, set that as my startup project, switch back, open the same, start diagnostic tools without debugging. And instead of CPU usage, I'm going to select memory. By the way, the memory usage tool supports debugging both native and managed memory, but in this instance, I'm only going to look at managed memory. So I'm going to hit start. This launches the tool under the profiler. What I'm going to do, I'm going to take a snapshot. At this point, what we're doing is we basically take a heap dump. We take a complete dump of the managed heap and store it in our profiling tool. You can see that we take a simple screenshot, so it's easier for you to understand what context or what point in your app did you take this particular heap dump. We show a live memory graph of the private bytes that's being consumed by the application. We show things like, hey, did you actually GC? We'll actually show points where the application GC'd. If you really want to force GC yourself, for example, if you want to make sure a finalizer queue is dumped before you take a snapshot, you can just do a force GC. And when you do another snapshot, we automatically force another GC for you. So I can switch back to my application, switch back. I'm going to time entry, going to report view, and I'm going to take another snapshot. So I have 2 snapshots. I'm going to stop profiling. So in the RTM version, we didn't have features like force GC and everything. We just introduced in a later update to Visual Studio. So you can see that we tell you, hey, in the first snapshot, your managed heap was around 9.17 megabytes, and you had over 200,000 objects. But after I did a couple of operations, your application's memory grew by almost 3 megabytes and by almost 60,000 objects. So what happens if I click this link? When I open that link, we open up the managed heap sorted by types. So you can instantly see, hey, these are the elements that's taking the maximum amount of memory. If I go to data grid, you can see individual instances of that data grid. Oh, God, demo fail. OK, let's let me stop. Try that again. See, that worked. Some async thing. So you can see individual instances of your data grid. And if I select a particular instance, you can see all its referenced objects. You can see its paths to root. We even tell you its inclusive size. We even tell you which module it's coming from. So there's a whole bunch of information here for you to quickly inspect your managed heap, understand why certain objects are being held, why objects are alive, see what its roots are, so you can make sure you null those roots in order for the entire tree to actually get collected. So we had a couple of features like force GC, module column, we improved performance. So I highly encourage you to give a look at the managed heap tool. By the way, the same tool is available during debugging. You can now F5 an application and take snapshots on the fly. And you can inspect those heaps while you're debugging your application itself. There is a session by Andrew Hall tomorrow, I believe, where he's going to dive into these kind of things in detail. So I highly encourage you to visit that section if you want to see more debugging and diagnostic improvements. So comes my final demo. So you guys excited about Windows 10? Yeah? So I want to show you one specific feature in Windows 10. And in order to do that, I'm going to switch back to my slides for a sec. There is a session. I want to talk about adaptive layout approaches. Basically, how do you build your UI so that it fits different device families or different form factors? How do you do that? There are multiple approaches. The XAML team has done an amazing job this release to build certain controls and panels that do it for you. For example, datetime controls or split view controls automatically modify their layout based on the device family they are on. The second way, there's a new concept called adaptive triggers, and you can use visual states to resize your application based on the target device you're executing on. And finally, you have tailored views. I'm going to do a quick demo of tailored views. The rest of this thing, there is a session on Friday, I believe, 9 o'clock by Harini from the XAML team. If you want to know more about adaptive layout approaches, you should go for that session. So this is going to be really quick. So I have another universal application called Cookbook. It's a pretty simple app. I'm going to F5 this app onto an emulator first. I should have wound with the emulator. Somehow I closed it. This is going to take a couple of seconds. That's fast. Come on. Okay. It's a pretty simple app. Shows you a bunch of food types. You can click on appetizers. Okay, yeah, this thing is alive. My visual tree tool. Click on appetizers. Click on specific recipes and see the recipe. It looks pretty decent, right? Even for a mobile view, it looks kind of decent. It is well laid out. Kind of fits the device profile really well. But what if I try running this on desktop? If I run this on desktop or local machine, and I hit F5, go to appetizers, steam bun. This doesn't really look right. There's probably a better way for me to lay this page out, right? It's not taking available space. It's just looking exactly like the mobile layout, but it kind of looks horrible. Let's see how we can use tailored views. It's a new approach for adaptive layout to fix this. I'm going to stop debugging, switch back to Visual Studio, open Cookbook. I'm going to add a new folder and name the folder device family -desktop. This is a very specific name. You have to exactly use this. This tells Windows that, hey, there's a set of XAML files here that is specific for desktop. When you're loading a page and you see a version of that page in desktop, go load that instead of the one anywhere else. And I already have a prepared XAML file that looks great for desktop. I'm going to right-click, add existing item. Select the file. Just rename that file to just desktop remove desktop modified. Yeah, save that file. I'm going to rebuild. I'm going to F5 the application onto local machine again and see what happens. Now what Windows is going to do, when it tries to load up recipe instructions, it's going to first check, hey, is there a desktop version of it? If there's a desktop version of it, it just picks that instead. So I'm starting deployment. Now if I go to appetizers, steam buns, you can see the layout is now different. It's actually picked up a desktop version of that particular file. So this is pretty easy. This is one of the approaches of doing quick adaptive layouts in Windows 10. If you want more details, one thing you notice is that, hey, there is no XAML.cs here. That's because it's reusing the same XAML.cs of recipe instructions.xaml.cs. So you can have multiple XAML files. Basically, the dream of loose XAML files is kind of reality right now. So you can have multiple loose XAML files that all share a single view. And it's pretty easy to do it. If you actually, I don't have time right now, but if you go to the g.i.cs and take a look at initialize component, you'll see a new override for initialize component that takes any XAML URI. So you can, based on your business logic, load any XAML file for any view that you choose now. So that's automatically generated for you in the code behind. So if you look at the generated code file. So that's kind of it. I think we have exactly. Yeah, so this is the session I was talking about. I believe this is on Friday, 8 or 9 in the morning. Yeah, 9 to 10:15. Another thing that you might want to attend is a debugger tips and tricks. It's pretty awesome. They'll probably show a bunch of the diagnostic tools while debugging as well. And please evaluate the session. Helps, it really it improves our, we do a better job next year based on your feedback. And that's it. So feel free to reach out to me anytime if you have any questions. My email is there. My Twitter handle is there. Either direct message me or directly send me an email. I'm pretty responsive. So look forward to hearing from you. If you have any questions, we can take it now. We have the room till 4:30, so we're good. Thanks, guys.